Hello, in this video I will explain how to find the centroid of a triangle, area of a triangle, when you have three vertices A, B and C, and then I will explain some examples how to find the area of a triangle and how to find the centroid of a triangle when you have the vertices A, B and C. So first, number one, centroid of a triangle. So first I will deduct the formula to find the centroid of a triangle. So let us consider here A, B and C are three vertices, A x1, y1, B x2, y2, C x3, y3. Okay. So now we know that centroid is the intersection of the all medians of a triangle. So here median is AD, B and CF. So then we take G, and we also know that the centroid divides the median into 2:1 ratio. That means AG by GD is equal to 2/1. Now since G is the centroid, we have to find the G. Now first find the midpoints of BC by using midpoint formula. This is x2 plus x3 by 2, y2 plus y3 by 2. Similarly, E, x1 plus x3 by 2 and y1 plus y3 by 2, and F, x1 plus x2 by 2, y1 plus y2 by 2. Now, in the line AD, see in the line AD, G is here, the ratio is here, and your A and D is known. So you can use here internal section formula. Your x is mx2 plus nx1 by m plus n, and y is my2 plus ny1 by m plus n. So apply this formula here. So you get the coordinate of G, that is centroid, the axis will be, so m is 2, and x2, say this one is x2 by 2, and x1 is here x1 divided by m plus n, that is 2 plus 1. So after simplification, we will get x1 plus x2 plus x3 by 3. Similarly, the coordinate 2 into y2 plus y3 by 2 plus 1 into y1 whole divided by 2 plus 1. After simplification, we will get y1 plus y2 plus y3 by 3. So complete. So this is the formula, or this is the coordinate of centroid of a triangle when you have three vertices. So the axis is sum of all axes of ABC divided by 3, and your ordinate is sum of all ordinates divided by 3. Okay. So now, so this is your formula. Now we will construct the area of a triangle. How to find the area of a triangle? So first we will deduct the formula, then we will do some examples. So let us consider a triangle with vertices ABC. So first draw a Cartesian plane, rectangular Cartesian axis. Say this is your x O origin x dash. This is y dash. So here x O x dash and y O y dash are perpendicular lines. So now draw here a triangle. Say this is your A, x1, y1. This is your P x2 y2 and C x3 y3. So then we have to find the area of this triangle. So first we will draw perpendicular lines from A to the x-axis, from B another perpendicular line. So give here, say this is your D, this is your E, and draw another perpendicular line from C to X, the x-axis. So say this is your D, E, F. Now, since these all are perpendiculars, now your required area is this one. Now to find the area, so area of triangle ABC equal to, we can write area of the region DEAB plus area of the region EFCA minus area of the region DFCB. Now each of this region is nothing but a trapezium. So we know that in case of trapezium, the area of a trapezium is half into sum of parallel sides into height. So in case of DEAB trapezium, here this one is your BD is y2 and AE is your y1. So half into y2 plus y1 into height is here DE, which is nothing but x1 minus x2 plus then area of EFCA. So here A is y1, so half into y1, and CF is your y3 into, and height is EF, so EF you can write x3 minus, you can write OF minus OE, that is x3 minus, here is x1 minus half into, now area of the region or area of the trapezium DFCB. Here parallel sides are BD and CF. So BD is a y2 and CF is y3 and this height is DF, which is x3 minus x2. Now since area is positive, so we can take the absolute value. So give here absolute sign, this square units. So after simplification, take half common, give absolute sign. So we will get x1 y2 minus y3, then x2 y3 minus y1 plus x3 y1 minus y2, this square unit. So this is the area of triangle, say this is delta. So whenever you have three vertices A, B and C, then if you put here, you will get the answer. So now you can find the area, or you can deduct this formula in a simpler way, which is shortcut. So let us try this. So first write the given coordinates in this way. So this is your x1, x2, x3, then x1, write x1 again, then y1, y2, y3, then y1. Now multiply from left to right in this way. So x1, y2, give plus sign, x2, y3 plus x3, y1, then give minus sign to here, right to left. So first one is your left to right, then here, or you can say some diagonal, you can multiply, you can consider this as a diagonal. So minus y1 x2, y2 x3, then minus y3 x4. So this is nothing but after if you multiply this, then you will get this one. So give here absolute sign. So give here half. So this is the required area. So in this way, you can find the area of the triangle, or you can deduct the area of the triangle in terms of the coordinates x1, y1, x2, y2, and x3, y3. Okay. So now we will do some examples. So let us take examples. So first we will discuss how to find centroid of a triangle whenever vertices are given. So take one question or problem. Find centroid of triangle ABC where the coordinates are, say you A is 0, minus 1, then 5, 2, 6, 3. So this is, say, this is your B, this is your C. So we know that the centroid formula is x1 plus x2 plus x3 by 3. So this is your abscissa. So 0 plus 5 plus 6, 0 plus 5 plus 6 divided by 3, which is 11 by 3. And your ordinate is y1 plus y2 plus y3 by 3. So which is minus 1 plus 2 plus 3. So minus 1 plus 2 plus 3 divided by 3. So here we'll get 4 by 3. So in this way you can find the area of centroid of the triangle when vertices are given. Now, okay, so now we'll move. I will take another example to find the area of a triangle. So let question 2. Find area of triangle ABC where A, the vertices are. So take one example. Let us take you A is 3, 8. B, you can take B, minus 4, 2. C, 5 minus 1. So your delta, that is your area of triangle. So write first coordinates, the x coordinates 3, here is minus 4, here is 5. Repeat the first code x1, 3 minus 4, 5, 3 minus 4, 5, then again 3. then 8, here is 2, here is -1, and repeat 8 here again. So the area of triangle ABC will be half of absolute sine 3 into 2 6, then plus 4, then plus 40 minus this will be plus 32, then minus 10, then minus is plus 3, this square units. So this will be half of 6 plus 4 10, so this will cancel. Then here is 35, this 75, this square unit. So in this way you can find the area of a triangle whenever 3 vertices are given. Okay. So since here is absolute sign and the 75 here is positive, so you can write here 75 by 2 square units. Okay. So now a very important note for area of a triangle. Note: if area of a triangle ABC is 0, that is your delta is 0, then ABC must be collinear. This is a very important part of area of a triangle. So sometimes problems comes in exam. Suppose you have to show that the points are collinear, then you can use the area of triangle formula. If the area is 0, you can simply directly say that the points ABC are collinear. So that means, so here you can write that since area is 0, so your formula x1 y2 minus y3 plus x2 y1 minus y3 minus y1 plus x3 y1 minus y2. So this should be equal to 0. So that is x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2 equal to 0. So whenever you have to show that the points are collinear, you can put here, and if the value is 0, then the points will be collinear. Okay. So let us take one example, that if the area of a triangle is 0, then find the value of some unknown constant. So let's take one example. Say you have, if, take this question as if A, B, C are collinear on first write here points. If A, say this is 0 minus 1, B 2 A, C 1 2 are collinear, find k. So what will be solution here? So since the points are collinear, so your solution will be like this. Since A, B, C are collinear, so we must have, so this is equal to 0, or you can write absolute sign. You can use this formula, or you can write the shortcut method. So write here first 0, abscissas 0, 2, then 1, then 0, then minus 1, here k, then 2, then minus 1. So write first here delta. So this is half of modulus of this one is 0 plus 4 minus 1 minus this one is plus 2. So this multiply minus k, this one is 0 modulus n. This should be equal to 0. So then here 4 to 6, so 5 minus k modulus equal to 0. Now if you remove here plus minus sign, or if you remove here modulus sign, so here plus minus 5 minus k will be equal to 0. So that is your here k will be your plus minus 5. So in this way you can find arbitrary constants wherever you have given that the points are collinear. Okay. So this is all about centroid of a triangle, area of a triangle, and their application in the coordinate geometry.